Hey everyone, hopefully you guys are doing well, hopefully you guys are being safe at home, your families are all safe, hopefully these lessons have been helping and you're doing well with the other classes. Today, what we're going to talk about is something called inscribed angles. And again, this shouldn't mean anything to you whatsoever, but I promise it will make sense in the end. And so different kinds of angles that we worked with. We dealt with essential angles, and what essential angle was, what we did from a few days ago, was you have a circle, right? Let's call it circle H. You have the center of the circle. When you have a line going from the center of the side, it's a radius, and what we've been working with. What we're looking at here, it's not an inscribed angle. What's it called is a central angle. And the reason it's called a central angle is because it's in the center. And we learned from the other day's lesson, which is if this central angle, just making up numbers, if that's 20 degrees, this arc over here that corresponds to it would also be 20 degrees because when it's a central angle, all the same. Whether you have a circle inside here or you have a circle on the outside, circle always adds up to 360 degrees, which is why they're always the same. So again, that's a central angle. What we're going to work with today, it's an inscribed angle. And the difference between an inscribed angle and a central angle is that the inscribed angle, it's no longer in the center of the circle. Where an inscribed angle is instead of being on the center, an inscribed angle is actually now on the side of the circle. So again, what an inscribed angle is you have an angle that's on the circle. The vertex of the angle is on the circle. So let's say we were to call this AHL, right? The inscribed angle here, we would call it is angle AHL. And what makes this really easy is, let's say that, switch up the color. Let's say that the angle, and for sure we'll call it angle H just to reference it. Let's say that angle H was 30 degrees, right? If this was a central angle, it would be a lot easier because central angle would all be the same. When it's an inscribed angle, we know that this angle opens up to this arc, right? They actually go together, and it's always the one that's across from it, right? Because this angle is literally opening up to that arc. It's making that arc, and it's always opposite, always across. If the angle itself is 30 degrees, what we know about the arc that corresponds to it, it's always going to be double, always. So if the angle is 30, we know that the arc that corresponds to it's going to be 60 degrees. Always, it's always going to be double. Again, the arc is always going to be double the measure of the corresponding angle. So if the angle is 30, the arc opposite is 60 degrees, always double. So easiest way to remember it is arc is always going to be greater than the angle. It's always going to be bigger. And we know that the arc is always going to be 2 times bigger, which means if that's 30, the arc is 60. If, let's say, and again, it's just to show you that the numbers themselves don't mean anything, it's just the idea. If the angle was, let's say, 40 degrees, we know that the arc that corresponds to it's going to be 80. And again, always remember, the arc is always 2 times bigger than the angle. If, let's say, I were to get rid of this now, and you've been saying the arc is 2 times bigger than the angle, which also means the opposite, which means that the arc is 2 times bigger than the angle, means that the angle is 2 times smaller than the arc. And what I mean by that is, let's say that the arc that they give you is 50 degrees. If the arc is 50 degrees, the angle is going to be 25. And again, the way we know that is always, the angle is always 2 times smaller than the arc, and it's the opposite way. The arc is always 2 times bigger. So always remember, the angle is always smaller than the arc. Arc is always bigger than the angle. It's always going to be bigger than the angle. And the angle is always going to be 2 times smaller than the arc. Always. Always just remember that. It's always going to be double the angle. And that's what an inscribed angle is. Again, it's a little bit harder than the central angle just because it's no longer the same. But when it comes to inscribed angles, always remember the angle is always smaller than the arc. And the arc is always 2 times bigger than the angle. And that's all we're going to work with inscribed angles today. It's just getting that idea behind inscribed angles. And again, an inscribed angle, it's just an angle where the vertex, where the point of the angle is on the circle itself. It's not inside, it's not outside, it's on the circle. So again, for example, let's say we had a situation like this, and it's just to help you guys out. Let's say we had a situation like this, okay? Where we have that point, we have this point, we have the vertex here. Let's say that that's F, let's say that that's T, and let's say that that's U, right? And I'll tell you that I want to find the measure. I want to find the measure of arc FT. I want to find the measure of this arc. I want to find the measure of arc FT. And since it's an arc, we put an arc symbol, right? In order to find that arc, we need to know the measure of the angle that goes with it, that corresponds. So let's say that this angle here was, let's say, 42 degrees, right? If the angle is 42 degrees, don't forget, the arc that corresponds to it, the arc that's opposite it, is always going to be 2 times bigger. Which means if the angle is 42 degrees, you know that FT, we would just end up doing 42 times 2. And again, just means that it's 2 times bigger. And 42 times 2 gives you 84 degrees, which would give you 84 degrees. And it's just that. It's always remembering that it's going to be 2 times bigger. And you can see it. If that's 84 degrees, that's 42. It makes sense, because if that's 84, 42 is 2 times smaller, right? Now let's say we did the opposite. Let's say now that I gave you the arc. And I'm going to show you a few more examples with this then, because it's applying these ideas, which is what I want you guys to realize. Let's say again, I gave you a circle. Okay? And I'm giving you an inscribed angle. And again, it's inscribed because the vertex is on the circle, right? And now let's say I give you the opposite. Let's say that that's S, that's O, that's T. And let's say that I told you that arc ST, let me do this in a different color just to help you guys see it. Let's say that arc ST is 100 degrees, right? And now I wanted to find the measure of angle O. Okay, you can call it angle O, you can call it angle SOT, you can call it angle TOS. In the end, we can call it angle O. If I wanted to know the measure of angle O, since the arc is 100, right, corresponds to that angle, because it's always opposite, it's always across. If the arc is 100, we know that this angle is going to have to be smaller. And it's smaller because the angle is always smaller. We know that the arc is always bigger. So since we know that the arc is 100, if the arc is 100, the way we want to find this out is, since it's 2 times smaller, we will literally do 100 degrees divided by 2. And again, we're divided by 2 now because it's 2 times smaller. If we were trying to find the arc like we did before, if it's 2 times bigger, you multiply. So if it's bigger, it's going to be times 2. If it's smaller, it's going to be divided by 2. Which in this case, again, 100 divided by 2 gives you 50. So you know that angle O is 50 degrees. And again, if it helps, just to see it, we see that it makes sense, because again, the angle is always smaller than the arc. If that's 50, arc has to be 100. Remember, inscribed angles, it's always that relationship of 2. Either 2 times bigger or 2 times smaller. Now let's see if you guys can actually figure this out by applying it with more complicated